Good morning, sir. This is Harshi Reddy from CSCA section, and my topic is about introduction to sequential circuits. It belongs to the RS flip-flops. And this PPT contains introduction to sequential circuits and basics of flip-flops, and understanding the RS flip-flop, characteristics and behavior, applications of RS flip-flops, and their conclusion of the introduction to sequential circuits. And we can see the introduction to sequential circuits, and we go through the definition. Sequential circuits are digital circuits where the output depends not only on the present inputs but also on the past outputs. Purpose of sequential circuits. They are essential for storing data, building memory elements, and designing sequential logic systems. And significance of sequential circuits are sequential circuits form the backbone of modern digital systems, including microprocessor, memory units, and control systems. And basics of flip-flops. Definition of flip-flops are flip-flops basic building blocks of sequential circuits used for storing binary information. And types of flip-flops are mention other types of flip-flops are D, JK, T, and briefly construct them with RS flip-flops. Role of a flip-flops are flip-flops play a crucial role in maintaining state information and digital systems. And understanding the RS flip-flops. RS flip-flops are basic sequential circuits with two inputs, set and reset, denoted by S and R, and two outputs, Q and Q, and Q and Q bar, where S is set to 1 while R is at 0. The Q output becomes 1 and Q bar becomes 0. That is set operation. Conversely, when R is to 1 while S is at 0, Q becomes 0 and Q bar becomes 1. It is the reset operation. Both inputs at 0 maintain the previous state, while both at result in an undefined state to be avoided. RS flip-flops find applications in memory units, data storage, counters, and control circuits, forming the basis of more complex digital systems. And we can see the SR latch using NOR gate. And truth table of the NOR gate is if S is 0 and R is 0, Q is no change. If we take 0, S is 0 and R is 1, it is reset operation. In before slide only I told that S is 0, R is 1, it is a reset operation. If S is 1, R is 0, it is a set operation in NOR gate. In NAND, we can see the below figure. It is a SR latch using cross-coupled NAND gate. And truth table is if we give 0, 0 for S and R, it will give the indeterminate state. If we give S and R 0 and 1, it will give set operation. If we give S and R, S is 1, R is 0, then it will give reset operation. If we give both 1 and 1, it is storage state. Characteristics and behavior of the RS flip-flop. RS flip-flop has two inputs, set and reset. Detecting their behavior, they exhibit four possible states: set, reset, stable, and invalid. In set state, S equals to 1, R equals to 0. Q becomes 1 and Q dash becomes 0. Conversely, in the reset state, S equals to 0, R equals to 1. Q becomes 0 and Q dash becomes 1. When both S and R are 0, the flip-flop maintains its previous state. However, when both are 1, entirely an undefined state. And it is the applications of RS flip-flops. RS flip-flops are utilized in memory storage units, forming the foundation of registers and shift registers. They serve as essential components in the data transfer and synchronization circuits. RS flip-flops are integral to control systems, facilitating sequential logic and timing operations. In digital counters, RS flip-flops enable counting and state transition functions. Their simplicity and versatility make RS flip-flops valuable in various digital systems from basic to complex applications. And the conclusion of RS flip-flops are RS stands as a fundamental building block within sequential circuits, offering simple yet essential memory storage capabilities. And thank you for giving this opportunity.